This video is going to focus on the last piece of our last learning target, which is about graphing velocity versus time, which implies that we're also going to be talking about acceleration. At this point, you should pause the video and find this note sheet in your binder. Before we can start talking about the shapes of the graphs, there are three things that we need to remember. The first is that velocity, and not speed, velocity, goes on the y-axis, and that time goes on the x. Because of this setup, the slope is going to be equal to the average acceleration. In order to prove that the slope is going to be equal to the average acceleration, let's remember our slope formula. If our slope is equal to the change in the y-axis over the change in the x, rise over run, then our y-axis is velocity over our x-axis, which was time, and velocity over time is equal to acceleration. Now, if you have a velocity versus time graph and you have a straight line, that means you're speeding up at a constant rate. So you can either be going in the positive direction or the negative direction. Now, the positive and negative direction are things you define. Positive can be left, and if positive is left, then that means right is negative. It's really arbitrary, and it's kind of how you decide to word the problem. But in terms of the shape of the line, we're going to say if the slope moves away from the x-axis, the object is speeding up at a constant rate. All right, the next graph shape we're going to talk about is when there's constant velocity or constant speed, which means we will have zero acceleration. Because if your speed's staying the same, that means it's not changing. So if it's not changing, that means you're not accelerating. The first we're going to have, it's going to be above the x-axis. Remember, this is the positive direction. And then we'll also have an object going at a constant velocity in the negative direction. So if the slope equals 0, but does not lie on the x-axis, the object is moving at a constant velocity. And like I just said, if it's moving at a constant velocity, that means its velocity is not changing. So if the velocity is not changing, that means that the acceleration is also going to be 0. Now, slowing down is just like speeding up, but backwards. It's flipped. It's kind of like the mirror image. So if we're slowing down in the positive direction, our graph would look like this. If we're slowing down in the negative direction, our graph would look like this. So if our slope moves toward the x-axis, the object is slowing down. The reason that is because if you start up here that you're at a high velocity, and if you go down the y-axis, that means your velocity is getting smaller over time. And the same thing here. We're starting at a high velocity in the negative direction and coming back toward the x-axis, which would be 0 velocity. Now, if an object is not moving, which means it's stationary on a velocity versus time graph, that means the line is actually on the x-axis. I'm going to change my ink color so you can see it. That means it's going to be on the x-axis. So if our slope equals 0 and lies on the x-axis, then the object has no motion. Which means not only does the acceleration equal 0, but the velocity equals 0 as well. Now there are three expectations with the graphs. The first is that you understand what each shape means. The second is that you understand what's going on if I give you a graph like this. And the third is calculating the slope. So let's analyze what's going on in this graph here. For line A, which is right here, the object is going to be speeding up in the positive direction at a fast rate. We know this because it's a straight line moving away from the x-axis, it's in the positive quadrant, and it's pretty steep, so that's how we know it's a fast rate. In line B, it's a flat line, but it's not lying on the x-axis. So that means it's moving at a constant velocity in the positive direction. For line C, it's a straight line with a kind of a medium slope, and it's in the positive quadrant. So for line C, it's speeding up in the positive direction, but at a slower rate than A. Line D is the same idea as line B. It is a constant velocity in the positive direction. However, because it's higher on the y-axis, it's literally higher than B, it's going at a constant velocity, but it's faster than B. Line E, it's going down toward the x-axis, which means that this object is slowing down in the positive direction at a fast rate. Now you'll see that our line intersects the x-axis right here. This means that our object has stopped, if only for a brief moment. Now F, that's where things can get a little confusing because it's going into the negative quadrant. However, because it's a straight line moving away from the x-axis, that means this object is now speeding up in the negative direction at a fast rate. This may take a little while to marinate, but after tonight and tomorrow, you should understand this material a little better. Now we're going to go into our third expectation, which is to calculate the slope and understand what it means in terms of acceleration. So remember that if you want to solve for the average acceleration, you're going to use, we always know it's delta V over delta T, but that's our rise over run, or our change in Y over change in X. So if the slope is 0, then the acceleration is also 0, and the speed is constant. If the slope is positive, which means it has a positive numerical answer, then acceleration is also constant. If slope is negative, which means it's going to have a negative numerical answer, that means acceleration is going to be constant in the opposite direction. And again, you define what direction is positive, whether that's left, right, up, down, north, east, south, or west. So whatever you define as positive, the opposite is going to be negative. So just like we did for position versus time, we're going to use this particular graph to solve for the acceleration of the object. So from A to B, write this down here, we know that A, which is acceleration, is equal to the change in velocity over the change in time, which is our rise over run. So if we're going, which remember is y2 minus y1 over x2 minus x1. Our y2 coordinate is 3. Our y1 coordinate is 0. Our x2 coordinate is 2. And our x1 coordinate is 0. So it's 3 over 2. It's a really easy fraction to simplify, so it's 1.5. Now understand this is the same math as we did for position versus time. However, the unit's going to be different because look at what we're given here. We're given velocity in meters per second and then time in seconds. When we studied acceleration, we know that meters per second will simplify into meters per second squared. The next thing we're going to calculate the slope for is B to C. And we're going to shorten this kind of line of work because I think you guys have a better understanding of that now. But also, we know that it's a flat line. So the acceleration here is 0 meters per second squared. However, this line is not on the x-axis, which means our object is still moving because it has a velocity. So if we look at our y-axis and we see the y-coordinates and we go over here, we'll see that our velocity is equal to 3 meters per second. So just because the acceleration is 0 doesn't mean we're not moving. Because remember, acceleration is the change in our speed, not completely stopping. If we go from C to D, remember we know that acceleration is the change in velocity over the change in time, which is the rise over run. So if I'm rising, my rise would be from 3 to 5. So the difference between 3 and 5 is 2. And my run is the x, so it's going to go from 4 to 8, which is 4. The difference between those two numbers is 4. It's a really easy decimal to simplify. And our units would be meters per second or meters per second squared. And last but not least, from D to E, I'm sure you've all noticed that it's a flat line, so you're like, oh, well, the slope is 0, so acceleration is 0 meters per second squared. However, remember, if it's not lying on this axis, that means it's still moving, so you'll need to determine what the motion is. If we look at our y-coordinate, those are the same, so that means our velocity is going to be equal to 5 meters per second. So with that, that's what we're going to need to know for velocity versus time graphs. So the first expectation, knowing what the shapes mean. Second expectation is knowing how to kind of analyze a graph conceptually, or kind of what's going on. And the third expectation is to calculate the slope, meaning you're going to calculate acceleration using a graph.